Good afternoon, good morning, good evening, whatever it is you're watching. Thanks for watching. Today we're going to be covering section 9.2 covalent bonds. And of course, this is the next section on your CK12 packet. Now, we touched on this topic yesterday when we talked about chemical bonds. Chemical bonds has three categories or three types: ionic, metallic, and covalent. We already discussed the first two. We only need that last one, okay? And covalent, the lecture for today starts off with a question. Have you ever played tennis? I play tennis, and it's not as easy as it looks. When me and my husband went out there to go try it out, I kept hitting the ball over the fence. And trust me, that's not the goal of this game. The goal of this game is just to get it over the net. No, not for me. That is definitely a sport that is not for me. All right, so who's going to help me with the introduction today?
In a tennis match, two players keep hitting the ball back and forth. The ball bounces from one player to the other over and over again. The ball keeps the players moving together on the court. Where the two players represent the nuclei of two atoms in the ball represent valence electron. What would the back and forth movement of the ball represent? The answer is a covalent bond.
All right. So they're already talking in terms of, what's happening with those electrons? What's happening with the nucleus of each atom? So they're telling you that electron, right? That bond, those electrons, that covalent bond that's being represented by that tennis ball is going to have a back and forth movement. It's going to do some rotation around not only one atom, but both. Why? Because they're sharing those electrons equally. Okay? Well, sometimes equally, sometimes unequally, right? Depends on the electronegativity. But either way, you have a good idea as to what a covalent compound is going to look like. Now, when we talked about ionic, we talked about metals giving up electrons to nonmetals, and you had that creation of that anion and cation that created that electrostatic attraction that brought them together. When it comes to metallic bonds, well, we know that metallic bonds usually is the same atom, and that atom usually shares those valence electrons with the other atoms, right? And they're kind of those free flowing electrons. That's not the case here for covalent. Covalent compounds, they share electrons, but they share them a lot more differently. In the case of metallic bonds, all the electrons are being shared by all the atoms. That doesn't happen here. Here we're talking in terms of, certain amount of atoms, right? And it says here a covalent bond it's going to have the force of attraction. I'm sorry. A covalent bond is the force of attraction that holds together two atoms that share a pair of valence electrons. Those shared electrons are attracted to the nuclei of both atoms. So you have some attractions, just like you do when you had that cation and anion. But this time, that positive and negative force is the positive nucleus and the negative electrons. There is that attraction, right? The electrons from the opposite atom get attracted to the nucleus of the other atom, and the same thing and vice versa. Um, This forms a molecule, okay? And molecules can consist of two or more atoms. In the picture that you see on the right, you can see some examples where you have two atoms sharing electrons. In another example further in the presentation, you're going to see an example of a molecule that shares electrons between three different atoms. Covalent bonds I'm all tongue twisted today. Covalent bonds form only between atoms of nonmetals, okay? So if there's a metal in there, in the formula, in the compound, you cannot have a covalent bond, and you definitely cannot have a covalent compound. Okay, it must always be among or between nonmetals, whether it's two nonmetals or three or however many that are being connected. But they all must be nonmetals. And make sure that you remember on the periodic table, all of your nonmetals are going to be on the right side. Okay? Carbon, nitrogen, oxygen, fluorine, neon, argon, chlorine. Well, not necessarily neon and argon, but chlorine, bromine, iodine, selenium, sulfur, phosphorus, arsenic, silicon. All of those are the main nonmetals. The only one that's a nonmetal that's on the left is your element hydrogen. Okay, so I just wanted to review that real quick and just remind you where you're going to find these nonmetals. If you look at the picture, it's going to show something that's also common for covalent bonds. You can have what's known as multiple bonds, right? In the example on the left, for chlorine bonded to chlorine, which is known as a chlorine molecule, you are sharing how many electrons? How many electrons do you see that are being shared between these two chlorine atoms? Students, how many electrons are being shared by these two chlorines? And you can just post it in the chat. You don't have to come off mute. How many electrons are here stuck in the middle of these two atoms? Alexia, Mario, how many electrons do you count? How many red and blues do you see here in the middle? Oscar, Efrain, hello, anybody out there? How many electrons are being shared in this example right here? Here. What do you see? How many electrons are being shared? Oscar, Alexia, Mario, anybody out there listening? How many electrons are being shared for chlorine? Hello. Efrain, Jose, Arlette, Irvin, Alexia, Mario. How many electrons do you see in this orange circle right here that they're sharing? Is my mic on? Hello? Anybody out there? What was the question again? How many electrons are being shared in between the chlorine atoms right here that are circled? Two. Two. If you have two electrons, that's considered one pair, right? Anytime you're talking in terms of shoes, right, Irvin? You always say, oh, where are my shoes? Or where are my pair of shoes, right? You don't say, where's my Nike? Right? They always come in pairs, right? One for each foot. Same thing's going to happen for these electrons. If you have two electrons, you're going to call it one pair. And if you have one pair, you're also going to call that a single bond. In the case of oxygen, Irvin, how many are they sharing here? Four. Four. How many pairs is that? Two. You're going to now call that, if you're sharing four electrons or two pairs, you can call it a double bond. In the case of nitrogen, what do we got here? Three pairs. Three pairs. That's also now known as a triple bond. Triple bond. Very good. Thank you, sir. Appreciate it. All right. Which of the following was not discussed regarding covalent compounds? Which of the following was not discussed? Which one doesn't belong? It's multiple choice, guys. It is a multiple choice question. A, B, C, or D. What do you think? Can somebody pick one so that we can start discussing the answers and see which one applies? Can somebody choose an answer, please? What was not discussed about covalent compounds? A. Covalent compounds share a pair of valence electrons. B. Shared electrons are attracted to the nuclei of both atoms. C. Covalent bonds only form between atoms of nonmetals. Or letter D. Covalent compounds have free-flowing electrons. Which of them was not part of our discussion when it came to covalent compounds? Which one was not part of our discussion? Okay, now people are switching. They had said A, and now they're saying letter C. Covalent compounds only form between nonmetals. Guys, remember, look at the question. It says, which of the following was not discussed in the last slide? Right, very good. It wasn't letter C, that's for sure. We said that covalent compounds always have to be between nonmetals. Did we talk about free-flowing electrons, or is that another type of bond?
Oh no, we didn't talk about it.
Oh, did you forget? You forgot. All right, let's go back. It says here, a covalent bond is the force of attraction that holds two atoms that share electrons. The shared electrons are attracted to the nuclei of both atoms. Molecules always consist of two or more atoms, and covalent bonds always happen between nonmetals. What's the answer that's correct here? Which one did we not talk about right now?
D?
Correct. We said free-flowing electrons is only for metals. We talked about that yesterday. The answer is D. Covalent compounds have free-flowing electrons? No way. They're stuck where they're at. They are not free-flowing. All right, now covalent compounds and diatomic elements. Two atoms that are held together by covalent bonds may be atoms of the same element or different atoms. So technically you can have the same element bond and create a covalent bond with another element. Hydrogen bonded to hydrogen can come together, create a covalent bond. But is it considered a covalent compound? Well, let's wait and read. When atoms of different elements form covalent bonds, a new substance called a covalent compound results. So, if I got hydrogen bonded to hydrogen, the bond is covalent, but that is not a compound, a covalent compound. Why? Because they are the same element. You have to have two different elements, oxygen and hydrogen, nitrogen and chlorine. Whatever the combination may be, you just can't have carbon and carbon and that's it. You cannot have oxygen and that's it and call it a covalent compound. They can form covalent bonds, but they are not considered a new substance, so it cannot be a covalent compound. Water. A water molecule is modeled in the figure on the left. A molecule has the smallest particle of a covalent compound that still has the properties of the compound. So here you have water. It kind of looks like a little Mickey Mouse kind of head, right? Where you got your ears as hydrogens and oxygen is the face. Originally, hydrogen only had one electron. Originally, oxygen only had 6 valence electrons, right? We know that because oxygen comes from group 16. 16 means you have only 6 valence electrons. All right? So if you had 6 valence electrons, hydrogen had 1, well, hydrogen is going to come and it's going to attach itself to one of these electrons from oxygen, right? Now, hydrogen has 2 electrons in this energy level. That's a full energy level if you have only one. Same thing for this hydrogen. It has 2 valence electrons, right? It has the full energy level. Look at oxygen though. It originally had 6, but once those 2 hydrogens came and attached, and brought one electron, well, if you count your electrons, how many do you have? Well, 2, 4, 6, 8. That is the octet rule. We're done. We're done. We don't need any more elements. We don't need any more atoms. We don't need any more electrons. We already have those 8 valence electrons that we need. So it says here at the bottom, let me move this. How many valence electrons does oxygen atom share with hydrogen? Well, originally this guy had 1. So how many do we have? We have 1 pair, right? 1 pair means 2 electrons, right? And if you got 2 hydrogens, well, you look at the second question, how many covalent bonds hold water together? Well, you got 1 covalent bond on the right, you got another covalent bond on the left. That's a total of 2 covalent bonds in order to hold this water molecule together. Any questions? Any questions? Okay, you have paired deck question number 2. Very, very easy, okay? Which of the following is not a covalent compound? I'm sorry, which is considered to be covalent? So, how do you know if there's a covalent compound? 2 different nonmetals. 2, right? 1, 2, 1, 2. At least. You could have more than 2, but they all have to be nonmetals. So let's check out the compounds we have. Let's look up here. Number 1, Na, C, and O. That's sodium, carbon, and oxygen. Are all of those nonmetals found on the right side? Na, sodium, C, carbon, and O. Is that covalent or not? Where is Na, guys? Find Na. Find sodium on this periodic table. Is it over here in the corner, like we said, like all the other nonmetals? Well, except hydrogen, right? Is sodium over here in this left side or right side? I don't see it. Definitely covalent. So we would have scratched out number 1. We would have scratched out number 4, and then everybody else is definitely covalent. Very good. All right, almost done. The diagram in the figure below shows an example of covalent bonds between 2 atoms of the same element. In this case, 2 atoms of oxygen. The diagram represents an oxygen molecule, so it's not a new compound. So anytime you have 2 elements bonding, oxygen and oxygen, it's not covalent compound. It's still considered a molecule, but not a covalent compound. Why? Because it's not new. Oxygen normally occurs in diatomic, which means that there's 2 atoms of that element. It occurs in diatomic molecules. Several other elements also occur as diatomic molecules: hydrogen, nitrogen, and all but one of the halogens, right? Fluorine, chlorine, iodine, bromine. All of those would form diatomic molecules, but not covalent compounds. At the bottom, how many electrons do these 2 oxygen atoms share? How many covalent bonds will hold the oxygen molecule together? All right, so you're looking here, Irvin, Oscar. How many electrons? How many pairs? How many pairs do you see in this area? 4 electrons. 2 pairs, right? 4 electrons, 2 pairs. Okay, now remember that because I'm going to ask you another question. How many covalent bonds? If you have 2 pairs, you got 2 bonds. Now this is where where you come in, Irvin. When oxygen is a diatomic molecule, it shares 4 electrons. What type of bond is this? And I believe it's A, single, B, double, or C, triple. What's the answer for this question if there's 4 electrons? What would you pick, Irvin? A, single, B, double, or C, triple? And of course, we're talking in terms of bonds. Single bond, double bond, or triple bond. What do you think? What would it be called, Irvin, if you are sharing 4 electrons?
Double bond.
Double bond. Very good. Okay. There it is. It would be considered a double bond. Remember, how many number of pairs are sharing? That's going to tell you what type of bond. If you're sharing 1 pair, it's a single bond. If you're sharing 2 pairs, double bond. If you're sharing 3 pairs, triple bond. Very, very easy. Any questions on that one? Any questions? Thanks, Irvin. All right. Why covalent bonds form? And we kind of already talked about this, so I'm going to go through it quickly. Covalent bonds form because they give atoms a more stable arrangement of electrons. Remember, stability means 8 outer electrons. Look at the oxygen atoms in the figure above. Alone, each oxygen atom has 6 valence electrons. By sharing 2 pairs of valence electrons, each oxygen atom has a total of 8 valence electrons. The shared electrons are attracted to both oxygen nuclei, and the force of attraction is what holds the 2 atoms together within the oxygen molecule. In summary, a covalent bond is the force of attraction that holds together 2 atoms that share a pair of valence electrons. Covalent bonds only form between atoms of nonmetals. 2 atoms that are held together in a covalent bond may be atoms of the same element or different elements. When atoms of a different element bond together, it forms a covalent compound. Covalent bonds form because the shared electrons fill each other's outer energy level, and this is considered to be the most stable arrangement of electrons. Remember, the magic number that everybody wants, guys, is always 8. Unless it's hydrogen and helium, then it follows 2, the rule of 2s. Review questions. What is a covalent bond? Number 2, nitrogen is a diatomic element with 5 valence electrons. Create a model of the molecule of nitrogen. And then number 3, which of the following represents a covalent compound? A, B, C, or D?